Hello and welcome back to PHP Security Pitfalls. In the previous video we had a look at some cross-site scripting techniques, and in this video we'll have a look at cross-site request forgery, or CSRF for short. Now, what is CSRF? Tell you what, why don't we just construct a little CSRF attack ourselves? First of all, let's create a folder called CSRF. And inside of that we'll create an index.php like so. And also a functions file, and a login file, and a logout file. And that should do for now. Okay, first of all, session start is what we'll be putting into our functions.php. And we'll make sure to require that within all of our files. So that is functions.php here. And let's just copy that, and it'll be functions.php everywhere. Now, what we'll be building is a small and insecure website where you can transfer money from your account into another. Now, transfers will be made through index.php. Of course, you have to log in first. So we'll just do an if statement here, and we'll just check for a session index. Let's say logged in. Well, of course, that session variable should not only be available, but it should also equal true, like so. And then let's also provide an error statement in case the user is not logged in. So for that, let's just echo to the screen, you need to log in, man. So I'll just save all those files and have a look at the browser. And there we go, we need to log in. So let's go back to our application, and we'll just copy this and go to the login page. Now, I'm not even going to bother writing a form or anything. We'll just log in a user as soon as he enters this page. So we'll set logged in to true, and then we'll just add a header statement saying location index.php or something, just to redirect the user back to the application. Let's see what happens if we visit login.php. Okay, we are being redirected and the error message is gone, meaning we are indeed logged in. Now let's also supply a method to log out. In the logout page, we'll just do session unset. And then we'll also do session destroy, like so. And then once again, we'll set a header with a location of index.php. And let's see if that works. I'll just visit logout.php. As you can see, we've been there, being redirected to index.php, and we need to log in. Pretty secure application. Not. Okay, now in order to be able to transfer money, we need an account number, and we also need an amount. Now let's get the account variable from the query string. So we'll just do if set underscore get with an index of, say, account. And if that's present, we'll just set it to get account. And if not, we'll set it to 0. And let's just cast this into an integer. Okay, then we'll just copy this, paste it here, and change the variable names to amount, like so. Okay, it's time to actually transfer some money. If account is greater than 0 and amount is also greater than 0, then we'll just do a transfer. And if not, we'll just echo an error message to the screen. Let's say echo no transfer could be made, like so. Now, how can we quickly mock a transfer? I'll tell you what, let's create a file. It'll be called transfers.txt. And now what we'll do is open up our file, append the message, and then close it out again. So we'll start by setting a file name, and that would be equal to transfers.txt. And then we need to get the current contents of the file. So we'll set a variable called data and make that equal to file get contents, and we'll just pass in the file name there. Okay, now let's set a message, and it will be equal to a transfer of such and such and such has been made to account such and such and so. And then we'll take the amount, paste that in here, and we'll take the account and paste that in here. Now we'll take the data and append that with the message. And then of course we should store our file again, like so. And maybe echo the message to the screen just to get some user feedback. Now let's see if that works. Let's go back to the browser. Here's the error message telling us we need to log in, man. So we'll just do that. Visit login.php. Now it says no transfer could be made. So let's try and solve that. We'll just transfer an amount of $10, and we'll transfer that into the account of, account of 123. Now here's our user feedback. Let's see if a transfer has actually been made. We'll just open up transfers.txt, and there you go. Okay, and with that we've created our bank website. Let's just consider the following for a minute. I am an evil attacker and I would really like to transfer somebody else's money into my evil bank account. Unfortunately, when I go to the banking website, here I need to log into somebody else's account. And let's just for a minute pretend that I don't know how easy logging in is, but okay. I'm getting really frustrated because I'm pretty sure I can predict what query string I would need to use to make a transfer with. It would be something like this. Luckily, cross-site request forgery is here to help. I've got a little website of my own. It's located at a different domain, evilsite.dev, and here it is. Now, if somebody who was already logged into the bank site were to visit my site, could I exploit that? Well, I think I could. Let's open up the source code for the evil website. It's in the CSRF folder right here. Okay, now we're going to repeat the iframe trick that we used in cross-site scripting. So we'll just do iframe. And let's just go back and copy this URL here and paste it in like so. And of course, for an ambitious hacker like me, $10 is too little. So we'll just set that to, I don't know, 1 million. And then, of course, we'll set the account to 666, which is my evil account number. Now, I don't want this iframe to show, so I'll just set some styles as well. Let's say height equals 0 and width equals 0 as well. And let's set border to none. Okay, we have Firebug open. Now let's visit this site and reload the page. Now here you can see we are actually calling this URL here. And let's see how it responds. Now it says you need to log in, man, and that's because I, as an unexpected visitor, was not logged into the bank. So let's do that just now. Login.php. Okay, now I'm logged into the bank. If I visit the evil site and reload the page, without me knowing it, I'm also visiting this site as well. And let's see what the response is now. It says a transfer of $1 million has been made to account 666. And if we return to the bank site and open up the CSRF folder and the transfers.txt, then it actually says the same here. And I should have put a line break in between those sentences, of course, but okay, you get what I'm talking about. Now this is CSRF. Now the most rewarding pages for CSRF attackers to have somebody visit are state-changing pages. And that's pages that either change the state of the users, such as log in, log out, or maybe store something in the database, or create transactions. Okay, and now we're done with the scary bit. Let's see how we can fight this. Now, what is currently considered to be a good way to fight CSRF is to use a token. A token is a random string. A new random token is created on every page from which we can do a state change. Now, let's secure our page with such a token. Okay, let's open up index.php, and I'll tell you what, the first thing we'll do is create a CSRF class. So that will be csrf.php. And inside we'll create a class called CSRF. Now this will be a very simple class and it will contain two methods. The first one will be a method called get_token, and it will be a public function. And the second public function will be check_token. So we'll just change this into check. And what we need to do is pass in a token here. Now this function will basically create a token, and this one will check token against the session, like so. Okay, now the first task is to create a unique and random string. Now that's an entire course in itself, but we'll hack up something that is relatively random. We'll just call a native PHP function to create a random string. For the minimum, it will take 0, and for the maximum, it will take the maximum random number that can be generated. Now this is a pseudo-random number, so let's just solve this with microtime, I think, and we'll make sure to get that as a floating number. Okay, so this is our random string. Let's just cut this and run it through PHP hash. We'll use SHA-512, and then for the data, we'll just have the random number. Make sure we return that, and that's our token. Now let's see if we can get that to work. Well, the first thing I want to do here is not only require functions, but require our newly created class as well. And then we'll just get a new instance of CSRF and make sure we store that in a variable called CSRF. And then we'll set a token and make that equal to CSRF get_token. Now let's see what happens if we dump that token to the screen. Let's visit this page. Oh, I see I misspelled the file name. Okay. Let's just quickly rename that into csrf.php. No need to update anything, just rename it. Okay, let's try that again. And yes, that's what we're looking for. This is a huge token, but it's pretty unpredictable, and that's what we wanted. So, okay. Now that we have a token, let's store it into our session. I'll tell you what, let's just add that to our getToken method. Now this makes the code totally untestable, but it is a proof of concept. Instead of returning this hash, let's just store it inside of a variable called token. And then let's just grab the session and set an ID called token and make that equal to token. And once we've done that, we can return token, like so. Okay, now let's make it so that you can only log in from the index page. I'll just go to the bottom and echo a string. Now that will be a reference to login.php, and the query string will take a variable of token, and that will be equal to token. Now remember, we set this token at the top here. Let's just remove this. Of course, our link needs a text, so we'll just say login here, and then we need to close out our echo statement. So now, on the index page, we have a link to login where we add the token to the query string. Now the idea behind this is of course that within the login page, we'll just first do a check for the token and see if it matches the token inside of the session, and then only if it does, we'll allow people to log in. So first we'll need to require the CSRF page, and then we need to create a new instance, so CSRF is new CSRF, and then we'll just do a conditional here and say that if CSRF check token, and we'll need to pass in the token here, if that equals false, then we'll just die here and say you cannot log in. Something like that. Well, what could be a good way to get the token from the query string? I think we'll just write a public method for that. So we'll just do public function get underscore token underscore from underscore URL. And let's have that return something. We'll run an isset on the get array and see if we have an index of token. And then if we do, we'll just return that, and if we don't, we'll just return an empty string. And we'll just do the same for getting the token from the session. So we'll create a method called getTokenFromSession, but instead of querying the get array, we'll be querying the session array, just like so. And now we can safely set a token because it will be equal to CSRF getTokenFromURL. And just to clean this up, we could copy that, paste it in here, and delete this. And now let's write the business logic for our checkToken method. First of all, we'll set a variable called sessionToken, and we'll make that equal to this getTokenFromSession. And now we'll just do a quick check. First, we'll check for the length of the session token. Now that has to equal 128 characters, because that is the length of our hash. And now we need to repeat that for the past token, so that will be token here. And last but not least, what we need to do is make sure that the session token matches the token. Now if this is all true, then we'll just return true, and if this is all false, then we'll just return false, like so. Now that was a whole bunch of code I just wrote and I didn't do any checking, so let's try and do that now. Here we are on our index page. Now I'll just click login, and as you can see, this request called our login.php page, and we passed in the token, and then we were redirected to index.php, and that means that the tokens matched and we were logged in successfully. Now let's try and call this page from our evil side. We'll just copy this URL here. So we'll copy location, open up our evil site, and change the source for the iframe, like so. Then we'll just go over to evil side, reload the page, and as you can see, there's our request, and let's see what the response is. The response is you cannot log in. And that's because the token that is currently in my session has been changed, and it's not equal to this token here. And voila, there's our safeguard against CSRF. Now let's just make sure to secure our transfers against CSRF as well. And for that, we need to rewrite the index page. Okay, now the first thing to do is copy this link here and paste it here. And we'll just wrap this into an h1 tag like so. Now this will be sort of a default transfer link, and the text will just read transfer $10 into account 1234, and then we need to reverse those letters. And this link will go to index.php, so that's this very page, and then we'll set the amount to 10, and we'll set the account to 1234, and then we'll just add the token. Now normally when creating transfers you would of course create a form. It would have an input field for the amount, it would have an input field for the account, probably a select list or something, and then it would have a hidden field for the token. Now when you post that form you also post the hidden token, and then instead of matching against a token in the query string you'd be matching against a token in the post array. And actually, that is the way that CSRF protection is most commonly implemented. But okay, we'll just have to make do with a query string for this. Okay, now where can we do our token check? Well, I think a good place for that would be just before the actual transfer. So we'll just do a conditional here. And once again, we'll take the CSRF class and use the check token method. Where do we get the token from? Well, once again, we get it from the URL, so get token from URL. Now, if this token check equals false, then we know we're dealing with a CSRF attack, so we'll just do a die statement and say, you rascal you. And then, if this check returns true, we'll just execute this bit of code here, which is transferring the actual amount of money. Now, there is one thing that we need to take into consideration. We have to move this bit of code. Because just think about it. If we regenerate the token on every page load, we regenerate it just before we check it against the token in the session, and they won't match. So let's just remove this here and make sure we set a token only where we need it. So just before echoing the login link and just before echoing the transfer link, like so. Now let's see if I didn't make any mistakes. Now we are still logged in, so we're seeing our link to the default transfer. And as you can see, it includes amount, account, and token. Let's just click this link. And here we get it. A transfer of $10 has been made to account 1234. But now watch, we still have a flaw in our code, because what happens if I reload this page? Another transfer has been made, and another, and another. And I can even change the amount, or maybe the account. And that would still work. Now why is that? Well, it's because the token is not refreshed. So you want to make sure that immediately after you check a token, you set a new token. Now we could do that here of course, but chances are we'll forget. So for now, I'll just dive into our class and make sure I just reset the token there. So just before I return true and just before I return false. And let's refactor this code just a little bit, just to make it a bit more readable. We'll just say that valid equals this expression here, and then we'll just reset the token and return a variable valid, like so. And now if we go back and refresh the page, we get our die statement like we should. Okay, now a short disclaimer. This class, as with every class in this course, is just a proof of concepts to demonstrate the workings behind those attacks and the workings behind the fixes. This is code that has been crudely set up and it's not meant for use in a production environment. If you're serious about fighting CSRF, and I think you should be, then I recommend you look up some of the great libraries that are out there. For instance, the libraries that all the major frameworks use, such as Laravel and Framework. Okay, that's all for CSRF. In the last video, I'll point you to some resources that are great for exploring security fixes. I'll see you there.